here's a second proof we're going to do for congruent triangles. So let's look at our proofs again, and let's decide what we have. Well, what always goes first in a proof? The given. Okay? The given always goes first. All right? So what we're going to do, now on this particular proof, I did leave something out. And so AB is parallel to DC, and AD is also parallel to BC. I did leave that out, because I do things like that because sometimes my brain doesn't work. So anyway, those of you that have me in class know that. We have the given, so let's start off with our first given. AB is parallel to DC. How do I know that? Well, no shocker, it is given. So no, AB is parallel to DC. What I'm going to do now is I'm going to come up here, I'm going to mark AB parallel to DC. And let's determine if there's any information I can figure out now that I know these two are parallel. Well, imagine these are parallel lines. I always tell you to imagine these extended out. Just imagine they're extended. Well, we can identify a couple of types of special angles. One of our favorites, alternate interiors. Do you see how this angle and this angle are alternate interior angles? And now, because I know the lines are parallel, I can say they're congruent to each other. So angle CAB, do you see how I named it? CAB. You could also call it BAC. So I'm going to call it angle CAB is congruent. CAB or BAC is congruent to ACD or DCA, whichever one you want to call it. I'm going to call it DCA, because of the alternate interior angle theorem. Now, if you want to write it out, I told you you could write it out. You can write alternate interior angles are congruent when the lines are parallel. Now, it's your choice whether you write the entire thing out or if you just write alternate interior angle theorem. I know how some of you operate. You would like to write the least amount of information, which is okay with me. So I've established these two angles. Okay, is there anything else I can do with this? Not really. So let's move on to another given. Let's look at our next given. AD is parallel to BC. So now I'm going to do another given. I'm going to do AD is parallel to BC. And again, I know this because it's given. So I'm going to come up here and I'm going to mark these two parallel. Now, I like to use the extras so we can determine, you got these two lines are parallel and these two, technically you don't have to, but I always do. So we know these two lines are parallel. I'm using the double arrow just to distinguish these two lines from these two. You don't have to do that all the time, especially in a situation like this, but just bear with me here. Okay, because I know those two lines are parallel, we have those fun little angles again. Remember, imagine, now we're looking at these two lines being parallel. Imagine that these are extended. Imagine they extend out. I have these wonderful alternate interior angles again. If you look at the paper, if I were to rotate the paper sideways, you see how you've got a parallel line here, a parallel line here, in the alternate interior angles. Okay? So I'm going to use the same reason for number 4. I'm actually able to say this angle, which you can call DAC or CAD, I'm going to call it DAC, is congruent to this angle, which is either ACB or BCA. I'll call it BCA, because again of the alternate interior angle theorem. Okay, so we've established two pieces of that triangle, but we've got to find a third, and there's nothing really here that jumps out at us that says, hey, I'm a third spot. So let's look at what we can infer from the picture. Remember, we always look for things like vertical angles, right? Well, what's one key thing that you see here? They share a side, and that's our reflexive property. So we're going to use our reflexive property here. So for my reflexive property, I'm going to say AC is congruent to CA, the same side, by the reflexive property. And that's the reflexive property of congruence, okay? If you just put reflexive, that's the reflexive property of congruence. If you put reflexive, I'll take it, because I'm just that kind of teacher. I'm that nice. So now what we've done, if you see these two triangles, we've established something that'll tell us they're congruent. If I were to pull these triangles apart now, I've got a side, an angle, and another angle. So what postulate is that? Angle, side, angle. You've got an included. Remember, included means it's attached to both. An included side. So now I can go on to say my prove part, which is that triangle ABC is congruent to triangle CDA by angle, side, angle. That's the angle, side, angle theorem. Once again, all I had to do was show the two. I had to show the angle, the parallel lines gave me the alternate interiors, and then the reflexive property gave me the center side. So that was enough to give me my proof right there, which shows you how those two triangles are in fact congruent by angle, side, angle.